So thanks very much, and hello everyone. And it's great to be able to talk today. And I'm going to cover some of the high-level issues on this broad topic of air quality and climate change, which is a really broad domain. And I guess what we're moving towards, as has already been alluded to, is more of an integrated view of these two distinct environmental challenges, and certainly within the research community, we have tended to treat these as independent issues with separate people working on climate change and separate groups working on air quality. And that's also the case in how they've been treated in terms of the media reporting of these as issues. And it's also been, I guess, the way that they've been treated with policy and through regulation. And just within the UK, of course, air quality is an issue owned by our Department for the Environment, whereas climate change is an issue owned by our Department for Energy. So there have been all sorts of barriers, if you like, placed between the two. But in a way, it's surprising because the underlying causes of both are often the same things, and there are relatively few processes that are not significant contributors to both air quality and climate change at the same time. And so thinking is obviously beginning to move in the direction of trying to link actions which deal with two problems at the same time. Right, okay, if we go to the next slide, please. So the links between air quality and climate change are essentially in three domains, which I've got covered here. And I'll only really touch on two of these today. The top one is one that people have thought about for quite some time, certainly for probably more than 20 years, which is how will climate change itself impact on air quality? And that's predominantly asking the question around how physical climate change, regional climate and local climate may feed back on processes that either improve or degrade air quality. And certainly some of the first examples where this was raised as a real prospect of generating negative impacts on air quality was in the heat waves of 2003, when the links were beginning to be drawn out between the potential for higher temperature extremes over Europe and more extreme ozone pollution events. But it isn't a one-way street, and I'll show in a separate slide some of the more detailed aspects of this. But obviously climate change is likely to increase, certainly on the western side of the Atlantic, storminess and precipitation. It may change drought, which could change surface deposition. It may change stagnation events and many others. So there are lots of ways in which our changing climate could impact on some of the meteorological processes that define air quality. But what I'm not going to touch on much is that air quality pollutants can, of course, impact directly on climate change itself. And some of the main players here are things like black carbon, that's a warming agent, aerosols, which are often thought of as cooling, and tropospheric ozone, which is a warming agent as well. So air quality pollutants, although relatively short-lived, they are part of this basket of short-lived climate forces that do actually impact on climate and radiative forcing as well. But possibly now the sort of the biggest area of action and sort of research, and certainly one of the real active areas of policy, is around how climate mitigation may begin to impact on air quality. So some of the enormous changes that are being proposed to how we live our lives, how we power our lives, how we produce our food, and so on, are almost certainly going to impact in a fairly profound way on air quality. And I've just listed a few of them here, and I'll go into more detail later. But these obviously include things like electrification of the transport fleet, the adoption of renewables, energy efficiency, and so on. And the image on the right I'll come to in a moment, which is the pathways that a lot of countries are now setting out to reduce their greenhouse gas emissions to net zero. And so this is really where we're expecting there to be very large impacts on air quality in the future. So it's a complicated set of interactions. Climate change itself may have physical impacts on air quality processes. We shouldn't forget that some pollutants are radiatively active on climate. But I think the big one is how climate change mitigation is going to begin to impact on air quality. So let's go to the next slide. I'm going to take, first of all, this issue around the impact of climate change on air quality itself. And I'm just drawing here from a report that's about to be published by the Royal Society, which is looking at the effects of climate change and air quality. And this just expands somewhat the range of factors where a changing climate may affect processes that feed through onto onto air quality. And there are an awful number of areas associated with climate change where there are potential for impacts on air quality. And this particular grid here lists on one side the climate affected processes. In the center, what we've got is the impact that process change may have associated with climate on a range of different pollutants. And then a little bit more detail given on the right hand side. And the first thing that your eye is drawn to is that there are far more reds on this graph than there are greens. And so if you look through the really wide range of climate impacts that we expect to see on processes such as meteorology and natural factors like wildfires and so on, almost always the effect is negative. So that is that climate change is likely to lead to poorer air quality and across a range of different pollutants. And so some of these effects, we're already seeing. It's quite visible to see changes in many locations around the world associated with wildfires that have really large effects on virtually all pollutants. There are impacts likely to be seen through changes to wetlands and permafrost in terms of the deposition of pollutants. We may see changes in soil emissions from vegetative emissions, in the incursion of ozone from the stratosphere. Higher temperatures overall have a negative impact on air quality. The only ones, of course, that we can pick out that really seem to have a beneficial effect is where we see higher rainfall, which is typically pretty efficient at scavenging out air quality. So if we just take climate change in isolation, it is a driver of poorer air quality, which suggests that if we do nothing, air quality changes over the next 1 to 3 decades are likely to worsen air quality, stand still and continue business as usual with our air quality emissions. So it means we're going to have to work harder in reducing emissions just to maintain the air quality that we have at the moment. This is a very much a UK perspective. You see broadly the same thing if you look wider across Europe, but actually these squares change to slightly different colours if you look at other parts of the world. Okay, so we'll go to the next slide. So where I'd like to spend perhaps most of my time that I've got here is to look at how some of the issues associated with climate mitigation and the reduction in greenhouse gas emissions are likely to feed through into air quality. Now, the UK is one of a number of countries that's now published a commitment to try to achieve a net zero greenhouse gas budget by 2050. These are coming along quite frequently now, and I think we can expect to see more of these sorts of announcements made over the COP period. So these are an enormously complicated technological challenge for any country to achieve. And within the UK, we have a 6th carbon budget, which sets out the pathway to achieving net zero. And this requires action across a whole range of different sectors of society. And this is the one that's taken from the UK's Committee on Climate Change. This is, if you like, the best estimate of how we might achieve net zero by 2050. So this is a pathway that's considered to be technically feasible. So each of these areas, each of these individual strands, which takes the grey part of the graph down to net zero, is considered to be technically plausible to introduce. And so you start to work through these and see where will the action be to achieve a net zero greenhouse gas budget. Well, some of the reductions are achieved through simply reducing demand and improving efficiency. And in almost all the processes where we reduce demand and improve efficiency, that does tend to lead to an air quality improvement. It simply means a net reduction in the consumption, typically of fuels, whether that's in cars or the fuels used to heat homes. And then we get to the harder bits, which include the decarbonisation of the electricity supply, introducing lower carbon solutions. Electrification, which is the really big orange chunk of the graph, does an awful lot of the heavy lifting. And there's a lot of aspects to electrification. This graph doesn't show exactly how those individual sectors are made up, but electrification is a huge component of the 6th carbon budget. And then there are a number of issues to do with offsetting those emissions that can't be easily reduced or replaced with alternative energy sources. And this includes things like the planting of biomass and the production of biofuels, and also the use of things like carbon capture and storage as well. So you add them all together and you get down to zero. Now, when you look at it in this way, which is really about energy inputs and outputs, it's often quite hard to see the air quality effects. But in fact, you can take a carbon budget like this, and then you can expand it to look in more detail. And it's when you begin to look in more detail at the individual strands that deliver this overall net zero that some of the air quality impacts begin to emerge much more clearly. So if we go to the next. I was involved with a review of some of the impacts of the Committee on Climate Change's net zero plan. And when you look in detail, you discover there are very, very these individual. Okay. Am I back? Can you hear us now?
Yeah,
okay, great.
We lost you for a second, but loud and clear.
Yeah. Okay, right. So this is an analysis looking at the real findings. This is looking at some of the individual sectors that will have to change. And this is just one cross section through some of the actions that are going to be needed in the area of agriculture. And you can begin to look across each of these individual lines of action where you have to change, for example, how you use natural gas, how you change nitrogen use in agriculture, how you reduce consumption, how you change diets, and so on. These onto the projected air quality change. And generally speaking, what we find is quite a positive picture. So we tend to find a lot of greens and a lot of yellows when we do this analysis of how the individual lines of the net zero action plan will map out onto individual pollutants. So there's this sort of analysis for the UK runs to pages and pages long. But when you scan through those, you discover that you see a lot more greens and a lot more yellow than you see reds, which again is a really positive starting point. So most actions in net zero, when you look at them in detail, are beneficial for air quality, but not all of them. So sometimes you can come across things which are potentially antagonistic. And so there's one bright red dot on here, and that's the dot associated with widespread planting of trees within the UK, which has the potential downside of increasing biogenic volatile organic compound emissions, which in turn has a potential risk on ozone. So the real key here is to see around how we optimize these individual actions to get as many greens as we can, and where there are reds, we put in place strategies to eliminate the reds and ideally turn them into yellows or into greens. So to make this slightly more digestible, if we can go to the next slide, this is a summary for the UK on how we think net zero actions are likely to play out across some of the major domains of society. So what we've got here is a plot that shows on the right hand side, on the green arrow side, net zero actions that are likely to improve air quality, and things on the left hand side are actions that have the potential to potentially degrade air quality. And again, the real positive point from this is that we've got far more things on the right hand side going towards the green arrow than we have on the left. And so some of these are really obvious. So, you know, if you install renewable energy and you replace fossil fuel power stations, it's a clear win for air quality. You remove the SOx, the NOx, the PM, and so on. Slightly less positive for nuclear power, typically because you end up with considerable air quality emissions whilst you build the nuclear power stations. Again, battery electric vehicles are very, very positive for pollutants like NOx. Hydrogen engines and turbines are slightly less positive because they can release NOx emissions. Biofueled engines are a bit more questionable. Depends how you grew the fuel. And ultimately, some biofueled engines are really no different in terms of their air quality emissions than one fueled on fossil fuel. So transport, again, is a mixed bag. And if we're in the business of optimization, what we're trying to do is obviously promote those those interventions and those technical actions that have unequivocal wins for air quality rather than those where the outcomes are not so clear cut. Again, for agriculture, there are some real clear wins for air quality around the reduction of ammonia from fertilizer reduction, and similarly there are potentially large ammonia gains to be had from dietary change. So the UK's carbon budget assumes a reduction in meat consumption, which then again reduces the amount of ammonia emitted from animal waste. Again, reforesting and biocrops is again an area where we have to take some care because of the potential to change biogenic emissions. Buildings are an interesting case because this is where you can see we have some of the intersections that cross over into the negative side, and while some interactions of net zero on buildings and the built environment are definitely positive, and heat pumps and solar PV are examples of really positive interactions, there are issues around, for example, using biogas or hydrogen within the gas network that have some negative downsides potentially. And perhaps the big one is buildings' energy efficiency. One of the contradictions, of course, often with energy efficiency is a reduction in ventilation and a degradation in indoor air quality. So these are some of the things that we need to keep an eye on. And similarly, there are likely to be mainly positive impacts from behavioural changes to do with lifestyle, walking and cycling rather than driving, for example. And again, generally industrial decarbonisation is positive. So there's a lot going on here. So I just wanted to pick out towards the end some of these issues where we need to optimise and take a little bit of care. So if we go on to the next slide, what we're looking at here is these trajectories for the future, and we can see that the graph from the top left-hand side is showing historically how our emissions have changed over the last couple of 100 years, the period when we have data on emissions and then some projections into the future. And you can see for some pollutants, like SO2, we are getting quite close to fully eliminating this as a pollutant, and it's certainly plausible in a net zero future that this will be almost completely eliminated. But that isn't necessarily the case for all pollutants. We're likely to be able to reduce and remove a lot of NOx under most net zero scenarios, but not all PM2.5. We are likely to be left with a residual of PM2.5 even in 2050. Certainly a residual emission of non-methane hydrocarbons and VOCs. And it's very hard to see a future where we can really make substantial reductions in ammonia because of the need to produce food. So it is a mixed picture, and net zero doesn't cure all problems. It improves a lot of them a lot, but we will be left with some emissions even after a successful implementation of net zero. And this feeds through into different priority pollutants. At the moment, well, certainly we've gone through a period in a lot of Europe where nitrogen dioxide was an exceptionally high priority pollutant because of issues to do with diesel vehicles. It is rapidly diminishing, and I think we might expect, if all goes well and we implement net zero successfully, we might see that pollutant begin to disappear away into history, perhaps a little bit like lead and benzene and so on. We may see some reductions in PM2.5, but we know we can't get rid of it. It's always going to be around as a pollutant. And ozone, of course, as a secondary pollutant, is likely to rise in prominence as really the pollutant that we find hardest to control into the future. So just to finish off, if we go to the next slide, I wanted to just pick two areas around sort of net zero and air quality opportunities. And the first one is an opportunity around optimizing the technologies that we use. And it's hard to avoid in the UK a lot of optimism from our current government around the use of hydrogen. And there's been a lot of debate around how we're going to make this hydrogen. Will it be grey, blue, green, purple? Many different ways that it can be made. And we have a hydrogen strategy that talks about how we're going to grow our use of hydrogen. But we also need to think about the downstream consequences of exactly how we use it, because this has really significant implications on air quality. So whilst at the moment most of the debate is around how we produce it, does it reduce leakage of methane? Will we capture the carbon? Will we use renewables and so on? The actual usage scenarios really make quite a big difference for air quality. So if we use our hydrogen in fuel cells, they are genuinely zero emissions from an air quality perspective. So they are an absolute win for air quality. But if we combust our hydrogen, it still produces NOx. And so if we were to use our hydrogen, for example, fed into the natural gas network as a replacement for natural gas, we may well discover that our NOx emissions were not declining in the way that they might have been if we'd optimized around the use of that hydrogen in fuel cells. So this is just one example where we have to think very carefully through not only choosing a particular energy source, but thinking pretty carefully about how we actually apply that energy source and the exact technologies that we decide to use. Just moving on to the next slide. The other opportunity that we've got is around using, when we implement net zero, as a means to speed up the reduction in inequities and inequalities in exposure to pollutants. So net zero is seen as a kind of grand challenge that's going to take 30 to 40 years perhaps to implement. And this is a long time into the future before the entirety of these actions are going to be implemented. But if we target our net zero and we think carefully about which actions bring what benefits in the air quality domain, by reordering the speed with which we do things is an opportunity to potentially reduce some of the distributional inequities that exist in exposure to certain pollutants. And so what we have here is an example of the current distribution of nitrogen dioxide exposure in the UK, depending on socioeconomic group and various other measures of inequality. And the graph shows on the left-hand side, growing from 1, which is the most deprived communities, have the largest exposure, going through to the most wealthy communities, which have some of the lowest. So there's a question around how we implement net zero, and can we begin to flatten off this graph? So can we reduce the fact that the poorest in society typically are exposed to the most? And by looking at some of the actions in net zero, for example, around vehicle decarbonisation and electrification, we can find some unusual aspects. And on the right-hand side here, what we've done is a calculation of how that inequality in exposure changes between now and 2030 through the implementation of net zero. And we discover that some of those communities that are particularly exposed to vehicle pollution, and this is often the case in the East Midlands and the South East and the Northwest of the UK, net zero and decarbonisation of the vehicle fleet makes a major impact in reducing inequalities in exposure to pollution. But that's not across the board, because not all communities are affected by the same pollutant sources to the same extent. So whilst those communities and regions of the UK that have a lot of exposure driven by high densities of traffic benefit a lot from the implementation of electric vehicles, those communities that potentially get a lot of their pollution from industrial processes or power generation, they don't see the same changes over the same period. So there's a lot of opportunity here for net zero to be a driver of reducing inequalities by targeting individual interventions at certain time periods to help flatten off some of these graphs. Okay, so I think onto my final slide. Just as a summary, air quality and climate change, they're really closely linked to one another in all sorts of different ways, and almost everything that has an impact on climate as an anthropogenic process has an impact on air quality as well. The uncertainties associated with the meteorological aspects of climate change are really pretty uncertain. It is very difficult to predict at a regional or a national or a local scale how climate change is going to affect air quality. But overall, air quality changes that are driven by meteorological processes and climate do generally look like negative ones, so they're bad for air quality. The upside is that climate mitigations and net zero are really a major opportunity for cleaner air, and almost all actions within net zero are positive and improve air quality, with the caveat that there are a small number of subsectors that need some careful optimization to avoid negative effects. And perhaps the short-term opportunity here is around targeting net zero interventions and actions early on to deliver in some sectors and some geographies reductions in both carbon and air quality pollutants, which help reduce some of the immediate health inequalities that exist in the exposure to air pollution. So I'll stop at that point, and I really would like to thank all of the authors that were associated with an Air Quality Expert Group report back in 2020, which I've drawn on a lot here, and David Joffe at the Committee on Climate Change, and also a report that's about to be released from the Royal Society on air quality as well, and my colleague Shona Wild, who's done the work on inequalities. So thank you very much.